Hello and welcome to this lesson on sewage treatment. In today's lesson, we will understand and describe the stages of sewage treatment, as well as the purpose of each stage. So far, we have discussed the sources of wastewater from urban, agricultural, and industrial activities. You are already familiar with how these activities produce wastewater, its potential impact on the environment, and how this wastewater is treated. Building on this foundation, today's lesson will advance our chemical understanding by taking a closer look at the sewage treatment process. Let's delve into the main stages of sewage treatment, which ensures that wastewater is cleaned and safe for the environment and potential reuse. The first stage of sewage treatment is screening. Here, large objects like sticks, leaves, and trash are removed from the wastewater using screens. Imagine a giant sieve that catches these big pieces and prevents them from moving further into the treatment process. This is crucial because these objects could clog or damage equipment used in later stages. Once the large objects are screened out, the wastewater moves to the grit removal stage. This process helps to settle and remove heavier particles such as sand, gravel, and other gritty materials. These materials sink quickly to the bottom and are removed, preventing abrasion and damage to pipes and machinery in subsequent stages. Next comes sedimentation. In this stage, wastewater is allowed to sit in large tanks, where solids settle to the bottom, forming a layer known as sewage sludge. Meanwhile, the liquid portion, called effluent, remains on top. This process separates the solid and liquid components, preparing them for further treatment. Think of it as letting muddy water settle until the mud collects at the bottom and clearer water is left on top. The collected sludge from the sedimentation tanks is treated next. Bacteria break down this sludge in the absence of oxygen, a process called anaerobic digestion. During this process, the volume of sludge is reduced and biogas, primarily methane, is produced. This biogas can be harnessed as a source of energy. Additionally, the remaining stabilized sludge can be used as a fertilizer, enriching soils due to its nutrient content. After sedimentation, the effluent undergoes further treatment to remove remaining organic matter. This stage typically involves aeration tanks where air is pumped through the effluent. This introduces oxygen, which supports the growth of aerobic bacteria. These bacteria decompose the remaining organic pollutants, making the water even cleaner. Imagine tiny organisms eating away at any leftover dirt and impurities, breaking them down into simpler, harmless substances. Through these process steps, wastewater is transformed from contaminated liquid into a cleaner substance that can safely re-enter natural water bodies or be further treated for reuse. In today's lesson, we delved into the stages of sewage treatment, understanding the purpose and process of each stage. Each stage in this process plays a critical role in transforming contaminated wastewater into a cleaner substance, safe for the environment and potential reuse. This comprehensive understanding of sewage treatment helps us appreciate the chemical processes involved in making wastewater safe. Watch the rest of the GCSE chemistry course at Sophos Education.